Hello dear students, let us solve some multiple choice questions based on periodic motion. At first, let us review the related formulas and terms. Periodic motion represents simple harmonic motion SHM, in which particle moves to and fro of a mean position, just like this, just like a compound pendulum or simple pendulum which oscillates about a mean position. Suppose this is mean position, it moves to and fro of the mean position. This is simple pendulum. This graph represents a simple harmonic motion in which y represents the displacement of a particle from mean position and t represents time. Equation of simple harmonic motion is given by y is equal to a sin omega t, where a is maximum displacement from mean position and is called amplitude. Velocity of particle in simple harmonic motion will be equal to v is equal to dy upon dt, which gives a omega cos omega t, which can also be written as omega into under root a square minus y square. From this relation, velocity will be maximum at mean position here and its value will be a omega where y is 0, and velocity will be minimum at end position where y is equal to a. So v minimum will be 0 at end position and v maximum will be equal to a omega at mean position. V minimum is 0 at end position. Similarly, second derivative of y gives acceleration of simple harmonic motion, which gives minus omega square y. From this relation, acceleration will be 0 at mean position where y is 0, and acceleration will be maximum at end position where y is equal to a. So, magnitude of acceleration, maximum acceleration will be equal to omega square into a, which is at the end of. Here negative sign represents the nature of simple harmonic motion, which says that the acceleration is always directly proportional to the displacement from mean position and is directed opposite to the direction of displacement. Next, time period of simple pendulum is given by t is equal to 2 pi under root L by J, where L is the effective length of simple pendulum measured from the point of suspension to the center of the bob. Next, time period of mass vibrating with a spring is given by t is equal to 2 pi under root m upon k, where k is force constant of spring, which is given by the relation F is equal to minus kx, which is called restoring force. For two springs connected in series, resultant k is given by the relation 1 upon k is equal to 1 upon k1 plus 1 upon k2, and for the springs and for two springs connected in parallel like this, resultant k is given by the relation k is equal to k1 plus k2. Now first question, the question is the displacement versus time graph of particles in simple harmonic motion is shown in the figure. The maximum velocity of the particle will be. This is the graph between displacement and time. Amplitude of the particle is 1 cm and time period is 0.2 second. Time taken in one complete cycle is 0.2 second, and maximum displacement from mean position is a is equal to 1 cm. So solution to question 1, V maximum is equal to A omega, which is A omega is equal to 2 pi by T, angular velocity. A is given to be 1 cm into 2 pi and T is 0.2 second, 0.2. This gives 31.4 cm per second. So the correct option will be D. Next question number 2. The question is, the period of oscillation of a mass m suspended with a spring is 2 seconds. What will be the time period if the mass is 4m? Here solution to question 2. When mass is m, when m dash is equal to 4m, then T dash will be equal to 2 pi under root m dash upon k. It will be 2 pi under root m dash is 4m by k, which can be written as root 4 becomes 2 into 2 pi under root m upon k, which is 2 into t. 2 into t. 2 into t is 2 seconds. So it becomes 2 into 2 seconds means 4 seconds. So the correct option will be B. Next question number 3. The question is, the maximum velocity and maximum acceleration of a particle executing simple harmonic motion are 4 meter per second and 2 meter per second square respectively. Time period of oscillation is. Solution to question 3. B maximum is equal to A omega and mod of acceleration maximum is equal to omega square into A. V max is given to be 4 meter per second and omega square A is given to be 2. Therefore, A omega upon A omega square will be equal to 4 upon 2 is equal to 2. Here A cancels out and omega cancels out, which gives omega as 1 upon 2 and omega is 2 pi by t. Therefore, t will be equal to 2 into 2 pi means 4 pi second. So the correct option will be D. Next question number 4. The question is, maximum velocity of a particle executing simple harmonic motion with amplitude 7 millimeter is 4.4 meter per second. Time period will be. These are the options. Now, for SHM, maximum particle velocity is given by V max is equal to A omega, which is equal to A into 2 pi by t, because omega is 2 pi by t, and V max is given to be 4.4 meter per second. Therefore, t T will be equal to 2 pi A upon 4.4 and A is 0.007 meter, which is 7 millimeter. So T will be equal to 2 pi into 0.007 upon 4.4, which gives 0.0099 second, which is nearly 0.01 second. So the correct option will be B. Next question, question number 2. Next question, question number 5. The question is, a particle executes simple harmonic motion having time period t. What will be the time taken by it to move from mean position to half amplitude? So, solution to question 5. Here y is equal to half of amplitude and t is time period. Now y is equal to a sin omega t. When y is equal to a by 2, then a by 2 will be equal to a sin omega t. A cancels out and we get 1 by 2 is equal to sin omega t, which gives omega t as sin inverse of 1 by 2, which is 30 degree, which can be written as pi by 6. Therefore, omega t is equal to pi by 6. Small t will be equal to pi upon 6 omega, which is pi upon 6. Omega means 2 pi by t. Therefore, t will be equal to t upon 12. T upon 12. So the correct option will be D. Next, question number 6. The question is, time period of simple pendulum is, as we know, time period of simple pendulum is given by t is equal to 2 pi under root L by g. So B is the correct option. Next, question number 7. Question is, in simple harmonic motion, particle velocity is minimum at, as we know. Solution to question 7. For simple harmonic motion, particle velocity v is equal to a omega cos omega t, which is also equal to omega into a square minus y square. So v will be minimum when a becomes y. Therefore v minimum will be 0 when y is equal to a at end or extreme position. So the correct option will be A, extreme position. Next, question number 8. The question is, a particle executes simple harmonic motion starting from mean position. Kinetic energy of particle against time period is represented by the curve. These are the curves. So solution to question 8. Kinetic energy of particle executing simple harmonic motion is given by 1 by 2 m v square 1 by 2 m v is a omega cos omega t whole square. Therefore, kinetic energy will be maximum equal to 1 by 2 m a square omega square at t is equal to 0, and Ke will be minimum is equal to 0 when omega t is pi by 2, then cos pi by 2 will be 0. This means that 2 pi by t, which is omega, into t will be equal to pi by 2. Pi cancels out and we get small t as t upon 4. So the correct option will be this one. Here kinetic energy is maximum at t is equal to 0 and kinetic energy is minimum at t is equal to t by 4. Next question number 9. The question is, two identical springs are arranged with a block of mass m as in figure. The oscillation frequency of the mass is f. If one spring is removed, then the frequency of oscillation will be, these are the options. Here this is a block of mass m which is connected with two identical springs of spring constants k and k. The frequency of oscillation of this mass is f. When one spring is removed, then we have to find the new frequency. Solution to question 9. Here clearly two springs are in parallel because one end of this spring and one end of this spring is connected to the block. Other end of springs are connected to fixed supports. Therefore, two springs are in parallel, and we know in parallel K resultant will be equal to K1 plus K2 means K plus K, which is 2K. Therefore, F will be equal to 1 upon 2 pi under root K P upon M. Question 1. When one spring is removed, then f dash will be equal to 1 upon 2 pi under root k upon m. Question 2. So equation 1 upon 2 gives, therefore from question 1 upon question 2 we get f upon f dash will be equal to under root k p upon k, which is under root 2 k upon k. K cancels out. Therefore f dash will be equal to f upon root 2. So the correct option will be D. Next, question number 10. The question is, starting from mean position, a particle in simple harmonic motion takes times t1 and t2 to cover first half and next half displacement in moving from mean position to extreme position. Then these are the options. Now solution to question 10. Here suppose this is a simple pendulum, this is main position, and this is extreme position. In going from main position A to B, y is equal to A, and at midpoint C, y dash is equal to A by 2. We know y is equal to A sin omega t, which is A sin 2 pi by t into t. At midpoint C, y is equal to y dash is equal to A by 2, and t is equal to t1. Therefore, above equation gives A by 2 is equal to A sin 2 pi by t into t1. A cancels out and we get two pi t1 upon t as sine inverse of 1 by 2, which is 30 degree, which is pi by 6 radian. Pi cancels and we get t1 is equal to, similarly at extreme position, similarly at extreme position B, y is equal to A, hence above equation gives A is equal to A sin 2 pi by t into t. A cancels out, which gives 2 pi t by capital T as pi by 2, which gives t as pi cancels, t as t by 4. So, total time from A to B is small t, time from A to C is t1, time from C to B is t2. Thus, t will be equal to t by 4, but total t is equal to t1 plus t2, which gives t2 as t minus t1, t is t by 4 and t1 is t by 12, 12 taken LCM, t 3 minus 1, therefore T2 will be equal to 2t by 12, that is t by 6. Here T1 is t by 12 and T2 is t by 6. Thus, or this can be written as T2 can be written as t by 6 into 2 by 2, which becomes 2 into t by 12, which is T1, so 2 T1. Thus the correct option is T2 is equal to 2 T1, option B. Next question number 11. A pendulum clock keeping correct time. Pendulum clock keeping correct time is taken to high altitudes. These are the options. It will keep correct time, it will not keep correct time, its length should be decreased to give correct time, its length should be increased to give correct time. These are the options. Solution to question 11. For simple pendulum, time period t is equal to 2 pi under root L by G. At altitudes, G decreases, hence to keep T constant, L must be decreased, hence correct option is C. Yes, C is correct option.